Hi everyone, myself Dhanalakshmi and welcome to session 3 of chapter 1 sets of +1 mathematics. In this session, we are going to discuss the topics intervals as subsets of R, Venn diagrams, operation on sets which are union of two sets, intersection and difference of two sets, then their properties. Let us see one by one. Interval subsets of R. Interval as subsets of R. Let A and B be the two real numbers such that A is less than B. Then the set of real numbers is called an open interval. The set of all x such that x belongs to R and A is less than x less than B means x can take the values between A and B but not A and B. X can take all the values between A and B excluding A and B. That is what we call it as open interval AB. Next, closed interval AB is set of all x belonging to R such that A is less than or equal to x less than or equal to B. That is, x can take the values between A and B and including A and B. It can take all the values between A and B including the values A and B is what we mean by closed interval. Next, open interval from A to B including A but excluding B. So, when we say including A, it has to be closed interval sign. When it is excluding means you have to put open bracket. So, closed interval A comma open B is set of all x belonging to R such that since A is included you have to put the symbol as less than or equal to. So, A is less than or equal to x less than B because B is not included. The next is open interval from A to B including B but excluding A. So, A is not included, therefore, we put the open bracket for A and the corresponding inequality is less than. When B is included, we have to put close bracket for B and the corresponding inequality sign is less than or equal to. Therefore, we write open A closed B as set of all x such that x belongs to R and A is less than x less than or equal to B. So, these are the 4 types of intervals and let us see how we are representing these intervals in a real line. Okay. When we say open interval AB, it means x can take all the values between A and B but not A and B. So, how do we mark it in the number line? We just draw the line from A to B and A and B we put open circle, which means those 2 points are not included. So, we denote it by open circle and the rest of the values are included. So, the line is drawn there. The next is closed AB. You can see that it can take all, x can take all the values between A and B including A and B. So, A, B are included. So, we darken the circle. So, that is how we draw this number line. Next is open A closed B, which means A is not included. So, you put open circle. All the other points are included. So, you draw a line and B is included. So, you darken the circle. So, A is not included. So, you put an open circle. B is included, so you darken the circle and the rest of the points x can take. And the last interval is closed A comma open B, which means A is included, therefore you darken the circle at A, the rest of the points also we take, but B is not included. So, you use the open circle for B. So, wherever the points are included, we darken the circle. Wherever the points are not included, we leave the circle open, we do not darken it. So, we will make some of the notes. The closed interval 0 comma infinity defines the set of non-negative real numbers. Next, the set open interval minus infinity comma 0 defines a set of negative real numbers. The next is the set open minus infinity to open infinity defines the set of real numbers. Next important point is the intervals contains infinitely many points. We use the interval mainly when we discuss the real numbers. It has to be continuous. There should not be a break in between. So, and it contains infinitely many points. As said earlier, intervals are continuous and the number b minus a is called as the length of any interval, whether it is open AB or closed AB or open A comma closed B or closed A comma open B. Length of any interval is b minus a. Now let us see to a problem. Write the following as intervals. So we are given the condition x such that x is a real number and minus 4 less than x less than or equal to 6. So check the inequality, minus 4 less than x, which means minus 4 should not be included. Less than sign means that particular value is not included. So you use the open bracket. It takes the rest of the values till 6. Since there is less than or equal to sign for 6, 6 is also included. Therefore, we use the square bracket. So this is written as open minus 4 comma closed 6. Next, the set of all x such that x belongs to R and minus 12 less than x less than minus 10. You can see that both are less than sign, which means both the endpoints are not included. And always in the interval we should write the least number first. The first number should be always lesser than the second number. So we can write this as open interval minus 12 comma minus 10. Next example, 0 less than or equal to x less than 7. 0 less than or equal to sign is there. So 0 is included. Less than 7, 7 is not included. So we can write this in the interval form as closed 0 open 7. Next is 3 less than or equal to x less than or equal to 4. So both are less than or equal to sign. What does it mean? X can take both 3 and 4 and all the values in between 3 and 4. So we can use the close bracket for both the values, that is close interval 3 comma 4. Next problem, write the following intervals in the set builder form. So first question, open interval minus 3 comma 0. When you see the open bracket, those values are not included and the corresponding inequality which we should use is less than sign. So tell me, how can we write this? This can be written as set of all x such that x belongs to R, then minus 3 less than x less than 0. Next, closed interval 6 comma 12. When you see the closed interval, it means both the values are included. So whenever the values endpoints are included, we use the less than or equal to sign. So tell me, how can we write this? Set of all x such that x belongs to R, comma 6 less than or equal to x less than or equal to 12. Next, open 6 comma closed 12, which means what? 6 is not included, 12 is included. So how can we write this interval as set of all x such that x belongs to R and 6 less than x less than or equal to 12. So x can take all the values between 6 and 12, but it cannot take 6, but it can take the value 12. Next is closed minus 23 comma 5, open 5. That is minus 23 is included, but 5 is not included. So which we write it as set of all x such that x belongs to R and minus 23 less than or equal to x less than 5. Next, state whether the following is true or false. So let's see the first question. open interval 3, 9 is a subset of closed interval 3, 9. Let's recollect what we studied under the set in the beginning, the meaning of subset. We say A is a subset of B if all the elements of A are in B. So, here the open interval 3, 9 means what? 3, 9 are not included, the rest of the values are included. When we say closed 3, 9, 3 is also included, 9 is also included, the rest of the values are included. Naturally, the closed 3, 9 is the bigger set than open 3, 9. So, open interval 3, 9 is the subset of closed 3, 9 is true. So, this is true. Next, closed interval minus 5, comma 8 is a subset of open interval minus 3, comma 6. So, you can see that this minus 3 is not included. So, from minus 3 to 6 it can take the values. In that interval minus 4, minus 5, similarly 7, 8, 6 are all not included. Therefore, this closed interval minus 5, comma 8, it's not a subset of open interval minus 3, comma 6. Therefore, this statement is false. We will see to one more example in this. Open interval minus 3, comma 5 is a subset of open interval minus 7, comma 9. So, when we say open minus 7, comma 9, it starts from minus 7 towards the positive direction. It can go up to 9, but it cannot take both minus 7 and 9. But in that interval, surely we have this starting from minus 3 till 5 are included in that set. So, therefore, we can say open interval minus 3, comma 5 is a subset of minus 7, comma 9 is true. Next, we will see to Venn diagrams. What do you mean by a Venn diagram? So, Venn diagram is nothing but the diagrammatic representation of a set which is named after the English logician John Venn. These diagrams consist of rectangles and closed curves called circles. So, Venn diagram is a diagrammatic representation of a set represented in terms of rectangles and circles. The universal set is represented usually by a rectangle and its subsets by circles. Second note. The elements of sets are written in their respective circles. So, we will see to an example. Represent the following sets by Venn diagram. Set A is equal to the set 3, 4, 5, 6, 7, 8. Set B is equal to the set 4, 5, 6. And U, the universal set is set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, the question is to represent these sets in a Venn diagram. So, when we just study about these sets, we can see that the elements of B are contained in A. 4, 5, 6 are in B, they are also in A, which means it is clearly understood that B is the subset of A. So, let us write B first. So, first B comes. So, let us write the elements of B inside that circle. So, 4 is there, 5 is there, 6 is there. Therefore, the set B consists of the elements 4, 5, 6 is written within the circle B. Next, we will write the circle A there. So, in the set A, 4, 5, 6 are already included there. So, we have to write the remaining elements. What are the remaining elements there? 3, 7, 8. So, 3, 7, 8 together with 4, 5, 6, they all belong to the set A. Now, the universal set, the elements which are not in A and B belongs to the universal set, which means you have to write the remaining elements outside the set A. What are those elements? Let us see. 1 is in U, not in other two sets. So, 1 should be written outside the set A. Similarly, 2 also should be written outside the set. 3 is inside, 4 inside, 5 is there, 6 is there, 7 we have written, 8 also we have written, 9 should be written outside, and 10 should be written outside. So, this is how you represent the sets in a Venn diagram. Now, let us see to some operation on sets. There are some operations like union of the sets, intersection of the sets and difference of the sets. Let us see one by one. First one, union. So, what do you mean by union of the sets A and B? So, the union is defined as the set of all those elements which are either in A or in B or in both. In other words, you are going to unite all the elements, union, coming together, bringing together. You can remember it in that way. So, the set of all those elements which are either in A or in B or both. So, how can we represent it symbolically? The A union B is set of all x such that x belongs to A. Look at the word, it is OR. So, remember the word for union is OR. X belongs to A or x belongs to B. How do we represent this union in the Venn diagram? So, there is the rectangle is drawn for the universal set. Since two sets A and B are there, we will draw two circles. A union B means what? We are going to consider all the elements from the set A and also from the set B. So, we have to darken both the circles. So, both the circles are darkened, which means all the elements should be taken into consideration for the union. Now, let us see to some properties of the union. First one, union is commutative, that is A union B is equal to B union A. That is called as commutative law. The next is associative, that is A union B, union C is same as A union of B union C. So, in whatever way, whether it is you take A union B union C or B union C union A, in whatever way you take, the result will be one and the same. That is called as the associative law. Next is A union phi. We know that union is always a bigger set. So, A union phi means what? A is a big set here, which means the union will be A, and it is called the law of identity element, where phi is called as the identity of U. Next, A union A is equal to A. So, you get back the same set. A union A is equal to A, it is called idempotent law. Finally, U union A. Here which one is the big set? Universal set is the big set. Superset is universal set. So, U union A will be naturally equal to U. It is called law of U. Now, let us see to a problem in this. Let A is equal to set 3, 4, 5, 6, 7, 8 and B is equal to the set 4, 5, 6. You are asked to find A union B. So, what does the definition says? A union B is nothing but the set of all those elements which belongs to A or B. In other words, you can remember it as bring all the elements, unite all the elements together. So, A union B can be written as, so let us check, 3 is in A. So, 3 is there, 4, then we have 5 there, 6 is there, 7 and 8. So, all the elements from both A and B should be taken into consideration and it should be written only once. Okay? So, this is how we get the answer for A union B. Next, we will see the second operation on the sets, that is called as intersection of two sets. Means, it is nothing but the set of all those elements which belongs to A and B. It is a set of those elements, in other words, which are common to A and B. So, remember the word union word is OR. For the intersection, we use the word AND. So, symbolically, how do we write that? A intersection B is the set of all x such that x belongs to A and x belongs to B. Let us see how we are representing this intersection of sets by a Venn diagram. So, as usual, we take a universal set represented by a rectangle and two sets we draw in the form of the circles. So, you can see that A intersection means what? It is the portion which is common to both A and B. So, you can see that this shaded portion is the portion which is common to both A and B. So, A intersection B, the Venn diagram, we have to shade it in the middle portion. Now, let us see to some properties of intersection. A intersection B is equal to B intersection A. So, that is called as the commutative law. And we also know that A intersection B of intersection C is equal to A intersection of B intersection C. So, that is called as the associative law. Then A intersection phi. We know that intersection means what? It should be common to both. So, it should be always the least set. It should be always the least set. So, A intersection phi will be naturally equal to phi, which is called as law of identity element, and phi is the identity of U. Next, A intersection A. When you take the intersection of the same sets, you get back the same set. It is called idempotent law. Then U intersection A. So, universal set is the superset and intersection A means what? A is the least set here. Small set and this is A, therefore, U intersection A is equal to A. It is called law of U. Then the very important law, distributive law, intersection over union. So, A intersection B union C can be written as A intersection B union A intersection C, and this law is called as the distributive law. Make a note, if A is a subset of B, then A union B. We know that union means it is always the bigger set. So, when A is a subset of B, naturally the elements of A are contained in B, which means B is the superset here. Therefore, A union B will be equal to B. Next, if A is a subset of B, A intersection B. So, B is the superset here. Intersection always will be the small set there. It will be the least set there. So, A intersection B will be equal to A itself. Then, if A intersection B is equal to null set, if there are no common elements between A and B, then we call this A and B as disjoint sets. So, A and B are called disjoint sets if A intersection B is equal to null set. Now, let us see the problem here. Let A is equal to 3, 4, 5, 6, 7, 8 and B is equal to the set 4, 5, 6 and you are asked to find A intersection B. So, by the theory, what is A intersection B? The set of all elements which are in both A and B. So, you have to take the elements which belongs to A and also B. So, at a glance you know that 3 is in A but not in B, 4, 5, 6 are in both A and B, 7 and 8 are only in A. So, we know the answer common to both the set will be A intersection B will be equal to the set 4 is there in both the set, 5 and 6. Next operation, difference of sets. So, the difference of set A and B is defined as the set of all elements which are in A but not in B, and it is represented by the symbol A minus B. So, how do you define it? A minus B is equal to set of all x such that x belongs to A and x does not belong to B, A minus B. So, it belongs to A but the elements does not belong to B. In the same way, we can define difference of the sets B minus A as the set of all x such that x belongs to B, it is there in the first set, and x does not belong to A. B minus A is defined as set of all x such that x belongs to B and x does not belong to A. How do we represent it in the Venn diagram? So, universal set is taken. When we say A minus B, it is in A but not in B, which means only this portion should be shaded. Similarly, when we say B minus A, it is in B but not in A. So, only that small portion is shaded. Next problem, let A is equal to set 1, 2, 3, 4, 5, 6. B is equal to the set 2, 4, 6, 8. Find A minus B, the first question. What do you mean by A minus B? The elements which are in A but are not in B. So, you can check 1 is in A, not in B. So, we can consider 1, 2 is in both the set, 3 is in A, not in B. So, we can consider 3, 4 is in both the set, 5 is in A but not in B, 6 is in both the set. So, you can see that A minus B will be equal to set 1, 3, 5. Those 3 elements are in A but not in B. Now, let us find out B minus A. B minus A means what? The elements are in B but not in A. So, let us find out 2 is in B, 2 is in A. So, we cannot consider that. 4 is in B, 4 is in A. So, we cannot take it. 6 is in B, 6 is also in A. So, we cannot take it. It should be only in B but not in A. That is what we mean by B minus A. So, 8 is in the set B but 8 is not in the set A. So, B minus A, the answer will be the set 8. So, with this we come to the end of this session. Thank you.